See, our objective here is to learn basic mathematics, which is essential for learning physics for class 11th level. In previous two sessions, we have covered the topic of trigonometry. This particular session, we are going to master the topic of slope and graph. And the term slope is, I think most of you are familiar with. Slope of a line, this is we would have come across in terms of equation of a line. So slope of a line, and typically we use in notation is small n. Slope of a line is equal to y2 minus y1 divided by x2 minus x1. Okay, so here what we have done here, so in this case a graph is drawn here. Find slope, x-axis, y-axis, and these are grid lines, and a straight line is drawn here. Suppose we are given the task to find the slope of the straight line. Can we find the slope? Can we apply this formula here? Let's see how do we, first let's learn how to apply this simple formula without any error, with clarity, and also understand what it means. So let's do that. So for this, what is y2 minus y1, x2 minus x1? We need 2 points. So first of all, we need to select 2 points on the straight line. We can choose any 2 points for a straight line, but we choose 2 convenient point. Let's understand what does convenience mean. See, suppose I choose this particular point here, it becomes a little difficult to find x and y coordinate. But if I choose the point here, which lies on the intersection of grid lines, it becomes easy. So I choose 2 points which are convenient. So which are the points I have chosen? So I choose this is point 1, and I have chosen this point as 2. One more thing I have done here, see whichever 2 points I have chosen, the one which is on the right hand side, or one which has higher x coordinate, is numbered as 2. So I have chosen x2 is greater than x1. Though it is not necessary, it is convenience. What is the advantage of doing that one? If I choose this point, one on the right hand side, one which is higher x coordinate as 2, the denominator becomes automatically positive. So basically the sign of slope will depend on y2 minus y1. So but this makes it a little convenient. Okay, so we have chosen those 2 points. What we need to do now, in this formula, we need to know the coordinates of these 2 points. And how do we find coordinates? We drop a perpendicular from this point on the x-axis. This becomes x1. And similarly, we drop a perpendicular, foot of the perpendicular on y-axis. The y coordinate of that is y1. Similarly, from here, we drop a perpendicular. On x-axis, we drop a perpendicular on y-axis. And this is something, those who are not very comfortable with coordinates, some of the people are very quickly, they can read it off. The coordinate of this point is x coordinate is 3, y coordinate is 2. And here x coordinate is 1, of this is 1, 2, 3, 4, 5, 6, 7. And y coordinate is 1, 2, 3, 4. So we start from here. We read x coordinate, each count number of divisions. We start from here. This is how we read out y coordinate. But anyway, we mark this point here. So this is we find the coordinates of any 2 convenient points. So what is there in the denominator? Let's understand this point here. So this expression here, y2 minus y1 can also be written in terms of delta y. And this delta also is a notation. We use it very often. So whenever you use the term delta before y, it denotes a change in y. Similarly, delta x indicates a change in x. So y2 minus y1 can also be written as delta y. So if I from y2 here subtract y1, what is left is delta y. So this is delta y. So from here, what we have done here, for another way to visualize is from first point, you have drawn a horizontal line, and from second point, you have drawn a vertical line. And this is the kind of point of intersection here. So you notice this particular point. So what is the y coordinate of this point is same as y coordinate of point 1. And hence this becomes delta y. Delta y is y2 minus y1. And you can understand a similar way. And similarly, what happens? This particular point, x coordinate of this point is same as x coordinate of point 2. So what is this length from here to here? This becomes x2 minus x1. So we construct a triangle where from first point, we draw a horizontal line. From second point, I have drawn a vertical line. We form a right angle triangle. There are 2 sides here. The horizontal side is delta x and vertical side is delta y. Okay, so this are the small things. Basically, these are not something which need to be memorized. But if we think in a very systematic way, we'll make less errors and we have better clarity. So okay, so what is delta y here? From this point, we see delta x, we measure this direction. This direction is positive. X is positive in the rightward direction and y is positive in the upward direction. So what we notice compared to one, delta x 1, 2, 3, 4 units and delta y is plus 2 units. Since the second point is above, it is plus. And when the second point is below, it will come negative. Okay, so upward is positive, downward is negative. This is how the sign convention for y-axis is. So we put those values. So we could have written the y2 minus y1 and divided by x2 minus x1. We put those values, we get equal to 1 by 2. Or delta y is equal to 2 and delta x is equal to 4. Yeah, so that's how we find the slope. No problem. This simple one. And in this particular case, slope is positive. Delta x is positive because the slope is positive, but delta y is positive. So as we move from first point to second point, y has increased. So slope is positive when y increases with increase in x. Or we are saying as we go towards right, we go up as well. So as we move along the slope like this, x is increasing. If y also increases, it means slope is positive. We can also say when we move up as we move rightwards along the line. So if I move rightwards, if I move upwards also, the slope is positive. So number of ways we can understand, and best ways to understand slope is visually itself. When you look at the line, your mind should tell you the slope is positive, negative. We'll practice few more so that you have extremely good clarity about when is the slope positive and the slope is negative, just looking at the figure. Another point is, had we taken any other 2 points, we have taken 2 particular points here. If we choose any 2 points in the straight line and calculate slope in this fashion, we'll find the slope will come exactly the same. Slope will come equal to 1 by 2. Because that's a property of a straight line. Slope will be same for any 2 points of the line, which is the property of a straight line. Slope is constant. Any 2 points we choose, slope is equal. That's a straight line property. If slope is not equal, then it's not a straight line, it's a curve. So which we'll use this property later on. Another way to define slope. What is the other way to define slope? It's an m term here. M1 is delta y by delta x. So slope will be equal to delta y when delta x is equal to 1. So how do we state in words? What is slope equal to? Slope can also be defined as change in y for unit change in x. Let's understand what does it mean. Let's suppose from this point here. What is unit change in x? When we move on unit positive change. So from here, if I move towards right by 1 unit, x has changed by plus 1 unit. So what is the corresponding change in y here? So this, if I choose these 2 points, delta x is 1 and delta y is this much. How much is delta y? See here, we need to make a guess. If further divisions were there, we could have easily found it out. This is half. This is half of the division. So this way also you can understand delta y for unit delta x is also can be defined as slope. So slope can also be defined as change in y for unit change in x, and this can easily be understood from this expression. Further what? And this particular line, if I draw an horizontal line or if I extend this line, the angle it will make with the x-axis or angle it makes with the horizontal, both are same. Let's see, it makes an angle theta here. So suppose with protractor, I measure this value of theta angle, and from a tangent table, I read what is the value of tangent theta. The tangent of theta will be equal to slope. So m is also equal to tangent of angle the line makes with the x-axis. Okay. So in this case, the tangent of the angle, if I read this angle theta with the protractor, and from a table we find what is the tangent of that angle, the value of tangent is going to come to 0.5. So and that's why m can also be written as a tangent of theta. So this is something, what is the purpose of this particular side? What we should have understood, if a line is given, how to find slope by choosing 2 convenient points. And though it is not mandatory, it's not a rule. It's something like this. What does convenient mean? This is what I explained here. And slope can also be understood in terms of delta y by delta x. Slope is also equal to change in y or unit change in x. And slope is also equal to tangent of angle it makes. So a number of ways we can understand what the slope is. Right, so move on further. Let's understand slope with some more examples. So we can look at number of lines with different slope. So our mind can, moment we see a line, our mind should have get some idea what the slope is, positive, large, small, compare the slopes and all. So let's look at multiple lines here. This is purpose only to understand slope here. Let's do that. So this is the first line here. First line, what we notice here, if I choose this point as 1, on the left hand side, this point is 2. So between these 2 points, what is delta x? 1, 2, 3, 4, 5. Delta x is 5. But between those 2 points, is there any change in y coordinate? There's no vertical displacement. There's no vertical move. Delta y is 0, hence the slope is 0. So any horizontal line, slope is 0. Let's look at some more example. What about this line here? Again, this line also, delta x continues to be 5. But what is delta y? Delta y is plus 1. So what is the slope? Delta y is 1 plus 1, delta x is plus 5. So as x increases, y is increasing, slope is positive. Or if I'm walking along the slope towards right, as I walk along, I'm moving up as well. Slope is 1 by 5, a small slope. I can also write in terms of ratio, this is equal to slope is 0.2. Either 1 by 5, I can write as a 0.2. How about this one? All cases, what you have done, see, look at this. All cases, if I choose this point and origin, all cases x1, y1 is 0, 0. And we have more than x1, y1, let's every time look at delta. So delta is this point and this point. What is change in x coordinate? As I move from here to here, change coordinate is, the x coordinate is delta x is 5. And delta y is 1, 2, and 3. So if I construct a right angle triangle here, a y coordinate, but basically delta y is plus 3, delta x is plus 5. Slope is 3 by 5. Similar way, the slope, delta y is 5 and delta x also 5, slope is equal to 1. And slope is 1. So if this particular angle, can you guess what would be the value of angle here? What will be angle theta for this line? You can think visually also, what does the angle look like? Or if not, otherwise also you can think of what is this 1 be equal to? If this angle is theta, it will be equal to tangent of theta. For what value of theta is the tangent equal to 1? That is, if you recall properly, for theta is equal to 45, tangent is equal to 1. So this particular case, this theta will be equal to 45 when the slope is equal to 1. So all slopes less than 1 make an angle of less than 45. Slope greater than 1 make an angle greater than 45. That's another way we can understand. Let's look one more. The slope is even steeper. The slope is greater than 1, value is greater than 1, and the angle made by this particular line is greater than 45 degrees. And this here, how many delta y is 8 units? So 8 by 5, I could have also written as 1.6. Any slope greater than 1, angle is greater than 45. So all these lines, what you have done, I have drawn from origin. So basically, if I choose this point as 1, this coordinate is 0, 0. But is it necessary? It has to be passing through origin? Not necessary. Let's take one more line here. And visually itself, what I notice, slope of this line is equal to slope of this line. If slopes are equal, value of m is also equal. How do I get this value? Suppose rather than this line, if I was given this line, how I would have found the slope? I would have taken this point as first point, left hand side, and I would have taken the second, this is the second point. And from here, again, we can either I can draw or I can visualize a triangle. From here, it draw a horizontal line. So, and from here, it drop a vertical line. So it forms a right angle triangle. And this is delta x, this direction. We are moving from first point to second point, and we are moving from first point, this is delta y. Up to which point? Up to here is delta y. So from here, even though this line point is not on the origin, so we say if I use the understanding of delta, so basically I measure by construct a right angle triangle, and then in right angle triangle, what is the change in, what is the increase in x coordinate, what is the increase in y coordinate. So this also will come equal to 8 by 5. So otherwise also you could have noticed slope of this line is equal to slope of this line. Let's look few more. How about slope of this line? If I have to find this one again, if I choose this point as 1 and this point as second point here, and both are convenient point lying on the grid lines intersection, and right hand side is the second point. In this case, again, if I from here first make a triangle, form a right angle triangle. What I find as I from here, delta x is 1, 2, 3, 4, 5 units. Delta x is equal to plus 5. But compared to 1, per second point is at a lower level. What is delta y? Delta y is equal to minus 1. This is when the second point is lower. And and you can also think of as we move towards right along the line. So as x is increasing, y is decreasing. So when y decreases with increase in x, it means slope is negative, and this slope is minus 1 by 5. Delta y is minus 1. Okay, and in terms of steepness, see, sometimes we also talk of steepness. If you look at, if I compare these two, this is relatively flatter curve. Compared to this is steeper. So in terms of steepness, I noticed this red color line has equal steepness as some other black color line. Can you spot which other black line has same steepness? Yeah, one has positive slope, one has negative slope, but steepness is same. Magnitude of slope is same. Which two lines have equal magnitude? This particular line and this line. They have equal magnitude. One has slope of positive 1 by 5, other has negative 1 by 5. And the steepness are equal. So sometimes we talk about magnitude of slope. So these two have equal magnitude of slope, though opposite in direction. Okay, well, last one. What is slope of this line? Again, can you tell visually also? From here to here, what is delta x as I go from here to here? So if I move from here to here, so I'm going from point 1 to 2. To go from point 1 to 2, if I go like this, I have moved delta x plus 5, but delta y minus 3. From here to reach from first point to second point, so I have you go like this, delta x and then delta y, and we construct a right angle triangle. So I can think of moving from first point to second point like this, and then from here to here. Okay, so what is the slope? Slope is equal to delta y is minus 0.3. Sorry, minus 3 divided by 5. That's the slope. Minus 3 by 5 is the slope, and this particular line is as steep as this straight line. These two have same magnitude of slope. Okay, so some more exercise for you. Here, drawn number of 5 different lines here. This is kind of a small activity for you to calculate what is the slope of each of the line and check your answer. So you can pause the video, find the values, and check your answers are correct or not. This is again simple one. So pause, solve, and check. Okay. So we'll continue here. Line A, slope is 0. B will take those 2 points and we can easily calculate slope. Delta x is 4 unit, delta y is plus 2. So 2 by 4, that is 1 by 2. See also which 2 lines should I take. One line, this is coming on the intersection of grid line, and this point also. So again from here, if I look at this, something like this, I can think of delta x is plus 4. I start with 1 and this is 2. And delta y is 1, 2, minus 3. So this will be equal to minus 3 by 4. And line D here, again, let me see which 2 points I should mark here. I start from here. Okay, this point is coming on the grid line. So let me mark this point as 1. Which other point? Yeah, this point also comes on the grid line. So this is second point. So from 1 to 2, how do I move? You move like this. Delta x plus 3 units and delta y is up 1, 2, 3, 4. So this will be 4 by 3. And E also similar way, we can take this point here and this point here, and delta x is 5 and delta y is 1. So we can easily calculate, and we should get the idea also. Among this, if I ask you which curve is steepest, or sorry, which not curve, which straight line is steepest, yeah, visually itself this loop is steepest. And after this, yellow color, and then blue, and then green, and this is the yes, zero steepness, flat line. So you understand slope plus minus. We understand the steepness also. And we should also understand when is slope greater than 1, when the slope is less than 1. Slope is equal to 1 for whatever change in whatever delta x is equal to delta y. So angle is 45 degree. If slope is less than 1, angle it will make with the horizontal will be less than 45. Slope greater than 1, angle will be greater than 45. Right. Let's get familiar with the equation of the straight line. We can write equation in multiple ways. So, but we are going to use only one particular form as far as physics is concerned. So which form of straight line I'm going to use? We are going to use this form of straight line where y is written as y is equal to mx plus c. So you have x coordinate, y coordinate, and line is drawn. So whenever line is drawn in with in coordinate system, we can find the equation of the straight line. Which form? Y is equal to mx plus c. What does m indicate? M indicate is slope of the line. What is the term c? The term c is called y-intercept. Let's understand what does this mean here. Y-intercept is this the line here. The line will intersect y-axis at some point. C is the y coordinate where it intersects y-axis. Okay, so that's what the definition is. Let's practice this one. Let's get used to this idea of finding equation of a straight line y is equal to mx plus c. Okay, so this equation is slope form. What is the equation of this line here? Let's look at this. Two things we need to find. We need to find the slope and y-intercept. How do we find the slope? Okay, we have done the slope here. If I choose this point as 1, and this is the second point here. So what is delta x? 1, 2, 3, 4. And delta y is plus 3. So what is the slope? 3 by 4. So m is equal to 3 by 4. And this line intersects y-axis at this point where y coordinate is 0. Hence the c is 0. So we get the equation is equal to y is equal to 3 by 4x, which basically means in this equation, m is equal to 3 by 4. Slope of this line is 3 by 4. And c value, which is y-intercept, is 0. That's the equation of the rectangle line. Can we find the equation of blue color line? Can we find the equation? And those who are good, you should find the equation within about 10 seconds. Is that simple? So again, you can pause this video, find the equation, then check. But I will do it very quickly. One thing what I notice here, the blue color line is parallel to it, hence slope will be same. We can actually just select 2 points here. We can actually find out the slope, but visually also when I look at it, I find the slopes are parallel. 2 lines are parallel, hence slope are equal. So m value for this line also, what is the m value for this line? M will be the same as m value for rectangle. But there's a difference. These 2 lines are not identical, hence the equation will not be identical. Equation of blue color line will not be this. M is same, but this line intersects y. Which point it is intersecting y-axis? So this y-axis, this is the point of intersection. What is the y coordinate of this point? Y coordinate is above origin. So plus 1, 2, 3. So C value for blue color line is plus 3, which is y coordinate of point where the line intersects y-axis. So what will be equation? We have found the value of m, we have found the value of c. Hence we can write the equation. What is the equation of blue color line? 3 by 4x plus 3. So quickly, one more. This brown line also, again, pause, fine, check. Okay, but I'm not going to do that. I'll do it very quickly. Again, the slope is parallel. It is parallel to previous 2 line. M value be equal to 3 by 4. And what is y-intercept? So first we find is intersection point with y-axis. This is the point where it intersects y-axis. And since it is below the x-axis or it is below the origin, its y coordinate is minus 2. So c-intercept or y-intercept is minus 2. Now I have value of m as well as c. I can substitute in this form of equation and find this equation. So this equation y is equal to m is 3 by 4 minus 2. That's the equation of brown color line. So any line equation, we should be able to find the equation of a straight line drawn on a graph sheet or where. So let's apply our knowledge of graph and knowledge of slope to a typical physics application. What exactly mean by physics application? See, so far we were talking about something on the x-axis, some quantity on the y-axis, and these are variable undefined quantity. When we talk of physics application, we replace these 2 variables with 2 physical quantities. Let's take example what I mean. Let's see, there's a particle here, and this particle is moving along x-axis. This is positive direction of x-axis. So motion of particle along x-axis, we also call it 1D motion. And what would happen as the particle move at different instances of time, it will have different position. And at particular instance of time, it will have a unique position. It cannot be at the 2 different places at the same time. So there's a t and there's a corresponding value of position x coordinate. So there are two related quantities. Which are the two physical quantities we are talking about here? Time t and position x in meters. And whenever two physical quantities are related, those related quantities can be plotted in form of a graph. So graph will indicate nature of relationship between those two quantities. Let's do this case here. So motion of particle. So two related physical quantities can be plotted on two axes of a graph. So if we plot those two quantities, so see what happens. So in that case, on x-axis, if we have t in second, I replace x with t. So this value becomes 10 seconds, this becomes 5 seconds. And similarly on y-axis, we plot position x in meters. These are two physical quantity, and it can be any two physical quantity depending on which kind of physical kind of experiment or phenomena we are describing. So there's a graph now. Now it is not XY graph, it becomes position time graph. Okay. So what are these 2 points on the graph represent? We need to find the slope. So suppose we mark these 2 points. So let's first understand what these 2 points represent here. See, these 2 points, whenever any point on the graph represents, give a relationship for given x quantity, it gives you the quantity on the y-axis. So what does this point tell you? This point tells you what is the x coordinate corresponding to this point, 5 seconds. And what is the y coordinate corresponding to this point? It is 4 meters. And this is the quantity, this position 4 meters. So this point tells you at time t is equal to 5 seconds, the particle is at 4 meters. So it's a position in meters. So this is something it will represent somewhere in 4 meters. And what does 2 indicate? 2 indicate when time is at t is equal to 10 seconds. It is at a position of this, the position at t is equal to 10 seconds. At 10 seconds, it is at 8 meters. That's how these 2 points represent. So any point on the graph represents its position at that particular instance of time. So we understood those 2 points. Now the question is, what does slope represent? Let's understand slope. How do you find the slope? Now, if I mark this point here, see in this case of y1, y2 is to mark here. But now y quantity is replaced by x. So in place of y, I'll write x. So this will represent x1. And this point represents x2. And similarly from this side also, this represents t1 and this represents t2. So what is slope now? Slope will be x2 minus x1 divided by t2 minus t1. So let's write for xt graph. For yx graph used to be y2 minus y1 divided by x2 minus x1. Since it is xt graph, x2 minus x1 divided by t2 minus t. And which can also be written in form of change in x coordinate divided by time delta t, change in time. So this is time interval, and x2 minus x1 is a change in position, which is called displacement. So some of you recall part of motion of a particle, we will know these terms. Anyway, we'll deal with those terms in more detail in the chapter of kinematics. So we understood. So if you have to find slope, yes, we can find those values. What is x2? x2 is 8 meters. x1 is 4 meters. So basically, what is x2 minus x1? 4 meters. We like the unit also. It's just not value 4. It has a specific unit. So x2 minus x1 is 4 meters. And t2 minus t1 is equal to 5 seconds. And if you simplify, this is equal to 0.8. A unit also becomes meter per second. And what does this indicate? So it indicates when we have, see, basically one more way we can understand slope is it indicates rate of change. It gives you a rate of change. It also, see, I think if you recall the slope description, another one more way to understand slope is change in quantity on y-axis or unit change in x-axis. So we can understand here what does this represent? What is the displacement in unit time? Displacement per unit time is also called rate of change of x with t, which is velocity. So how do we read any graph? Whenever any graph is given, first thing what we need to identify which two physical quantities it represents. So we need to look at the label. What is the quantity on the y-axis? What is the quantity on the x-axis? So any graph represents relationship between physical quantities. And this particular case, the graph gives you position of a particle at every instance of time between 0 to 10 seconds. So let's practice few more cases of something similar. So again, we have a graph. First thing what we look at what is the graph indicates. Position, x meter. Why we used word x here? It is moving along x-axis. That's why its x coordinate was changing. Had it been moving along y-axis, position would have come as y meter. Okay, and this time in seconds. So what does this graph represent? We can understand from the label. It is position time graph. It represents position of a particle at various instances of time. The motion of a particle along x-axis, it gives you position of an object at all instances of time between 0 to 5 seconds. Every single instant, whatever we want to find out 1.1 second, yes, we can find out what is position. Every instance we can think of between 0 to 5 seconds, we can find where exactly the particle is. So can we easily identify what is the position of particle at t equal to 0 second and t equal to 2 seconds? And whenever I have question mark, think for answer also. What is the point corresponding to t equal to 0 on the graph? This is the point corresponding to t equal to 0 on the graph. And this is the point corresponding to t equal to 2 seconds on the graph. So position will be y coordinate of this point. Y coordinate of this point is 0 meter. And y coordinate of this point is 20 meter. So it means at 0 second, it is at origin. At 2 second, it is at a distance of 20 meter. Okay, that's what this figure indicates. So we can identify for every instance of time, we can find out position. Let's analyze this graph in more detail, see what more we can understand from the graph. The graph contains a lot of information, and that's why a lot of questions can be formed based on graph. Right now, we are dealing with a simple graph, which is form of a straight line. And later on, we look at a graph, which is not a straight line. If you have to write, can we write the equation of the straight line? So if it was XY graph, straight away I could have chosen any 2 points. Suppose I choose this 2 point here, and we calculate what is the delta X quantity, which in this case from 1 to 3, which is 2 seconds. And what is delta Y quantity is from 10 to 30, which is 20 meter. Okay, so this is 2 seconds and this is equal to 20 meter. So if I had to calculate slope, just like XY graph, delta Y is 20 meter, delta X is 2 seconds, slope would have come as 10. So equation of the line. So how do you find equation of line in form y is equal to mx plus c? I'll calculate slope and then I'll calculate y-intercept. Any line which is passing through origin, y-intercept is 0. So c is 0 and m is equal to 10. So had it been xy graph, the equation would have been y is equal to mx, which is 10. Y is equal to 10x. But in this case, x is replaced with t. So I'll replace in this equation also, I replace x with t. And in place of y is replaced with y-axis, it is represented by x in meter. So if we replace with appropriate quantity on x and y, it becomes an equation for the given graph, for the given label in the graph. So what would be the equation for the graph, which is xt graph? The graph also equation should be in terms of x and t, and equation will be equal to x is equal to 10t. So it's a very similar way we can. So any two physical quantity represented like a straight line, their relationship can be written in form of a linear equation between those two quantities. In this case, x is equal to 10t, and for any value of t, if we substitute in the equation, we can find the value of x coordinate. So what we have done, the graph we have converted in form of a mathematical equation. And reverse also is possible. Whenever mathematical relationship is given, we can form a plot in terms of graph. And this is what we have done. Okay, so what does this indicate here? Slope. We again like to understand slope here. What does slope indicate? Slope indicates a rate of change of position with time, which is called velocity. And more appropriate term is velocity. It is average velocity. So whenever we calculate from one per instance of time to other instance of time, it gives you average velocity between those two instances of time. So this expression implies average velocity between time t1 and t2. So in this case, can we find what is the velocity between t is equal to 2 seconds and 3 seconds? Yeah, 2 seconds, 3 seconds, we mark those 2 points. We calculate slope here between those 2 points. And we have already calculated the slope. Since it is straight line, slope is constant. and slope here indicates velocity. So here also, if we calculate average velocity between 2 and 3 seconds, it will come equal to 10 meter per second. And even if we have to calculate in 4 and 5 seconds, even then also will come equal to 10 meter per second, because it is a straight line. Slope is constant, and slope indicates average velocity. Okay, so this how we understood what the graph means. Okay, now this graph we are converting in form of equation. We understood what the slope indicate. From this graph, whenever graph is given, we can find out average velocity between any two instances of time. Now, can we also convert this graph in terms of visualization? So this particle is here. Can, in our imagination, make this particle move as per this graph given or as per the equation given? And if you have understood well, you can actually make this particle move. So you try it hard, and if you can make it move, it means you have that kind of willpower. You can make actually these things move. So look, keep looking intently and just make it move. I think it will move. So try it. As you start moving. 2, 3, 4, 5. Right. So what has happened? It has moved, starting from point 0. It has moved to a point where coordinate is equal to 50 meters. So it has started from x is equal to 0. Initial position was at origin. It has moved to 50 meters. And what is the time it has taken? If you had a stopwatch, you could have calculated. The time taken was 5 seconds. And it has moved at a uniform speed. It can move. So from here, again, if we have an action replay without slow motion in normal speed, you'll find this is 0. So as soon as we make it move, 0, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. It has taken equal time each step per second. It has moved by a distance of 10 meters. So you've done all three. The graph in equation, and equation you can also visualize what is happening. We understood slope also. Slope indicates average velocity. And if it is slope is constant for position time graph, it indicates constant velocity. Let's look at one more case here. Let's change things a little bit. So again, we have a graph here, and again, it's not XY graph, it's a physics quantity graph. First question comes, what does this graph indicate? So whenever question mark is time for you to think and answer yourself. And if you wish, you can pause the video, think of an answer, then again continue. What does this graph indicate? First thing what we should do, we should start looking at what are the labels. What is the quantity on y-axis? What is the quantity on x-axis? Y-axis, unlike previous case, it was position. Now it represents velocity. And what is the x-axis? Time. So it represents velocity at various instances of time. From which time to which instance of time? From time t is equal to 0 second to 10 seconds. So this is velocity time graph. It gives velocity of an object at all instances of time from 0 to 10 seconds. Right? What does the slope indicate? Slope indicates delta of quantity on the y-axis divided by delta of quantity on the x-axis. So let's do that one. If I have to do calculation, let's calculate the slope also. And if I calculate, let's take for calculation slope, we need 2 points. Let me call this point as 1.1 and this point is 0.2. So what are the coordinates of this point? Coordinates of this point, I have to write x coordinate is 0. And so 0 second. We'll write the unit also, because there's a second unit also involved. And what is the y coordinate of this point? This is 5 meters per second. So each division means if I look at the graph, what does this indicate? This is 0. So if it is 5 units is equal to 5 meters per second, it means each division is 1 meter per second. So this will be 4 meters per second, this particular point. What is the coordinate of this point if you have to write? So again, if I look at x coordinate is 10 seconds. So that is 10 seconds. And what is the y coordinate? I drop up a perpendicular on y-axis. This is the foot of the perpendicular. And that will be minus 4 meters per second. So this would be minus 4 meters per second. So we have 2 points. We have x coordinate quantity on the x-axis, and we have quantity on the y-axis. If we have to calculate slope, in case of y2 minus y1 divided by x2 minus x1, corresponding y-axis and x-axis quantities will come. It will be v2 minus v1 divided by t2 minus t1. So what is V2 here? In this particular case, V2 is equal to minus 4 meter per second, and V1 is equal to 4 meter per second. So it will be minus 4 minus of plus 4. So that will become numerator because minus 8 meter, and time is this is 10 second and this is 0 second. So it is, if you simplify, it will be equal to numerical values. There's a negative sign. Numerical value is 0.8 and unit will come meter per second square. So this is negative 0.8 meter per second square. Slope is negative. That's the negative term here. So it is decreasing. Velocity is decreasing, and slope is constant. And so some of you might be able to recall what does this term indicate here. This term indicate rate of change of velocity and average rate of change of velocity. And average rate of change of velocity, the term there's a so called acceleration. So whenever we have two physical quantity, the slope indicates a ratio of quantity on the y-axis divided by x-axis. Change in quantity in the y-axis divided by change in quantity in the x-axis. So unit will be this unit divided by this unit, and the slope may represent a third physical quantity. So in this case, the ratio or slope will indicate third physical quantity, which is called acceleration, rate of change of velocity. So how do you rate this term? There are two ways of stating this one in terms of what? Rate of change of velocity with time is equal to minus 0.8 meter per second, or I can also say negative indicates a decrease. Velocity is decreasing at a constant rate of 0.8 meter per second square. Why was the constant here? The rate of change is slope, and since the slope is constant, that's why I use the term constant here. Every second, so if we start with 4 meter per second, after 1 second, the velocity will become 3.2 meter per second. It will decrease by 0.8 every second. So in 2 seconds, it will decrease by 1.6 meter per second. So likewise, that's what is happening. So every second, the decrease is constant, which is indicated by constant slope. So this is velocity time graph, and slope of velocity time graph indicates acceleration. And since here it is a straight line, it indicates uniform acceleration. So this graph, we can say, is a velocity time graph of uniformly accelerated motion. One more practice question. So far we had only one line with one constant slope. Well, let's take one more example where there are two different lines. This is one line here. This has a different slope and this has a different slope. So it's not just one line, there are two line segments. In this case also, what kind of motion? This gives you position time graph. Where does the particle is at time t is equal to 0? At t is equal to 0, x coordinate is 0. It means initial position is at origin, or particle starts its motion from origin. Initial position means at where is it at time t is equal to 0. And if you want to understand the motion, what is happening here from here, and each division is 1 second, so this would be equal to 5 seconds. This will be 10 seconds, and this will be 15 seconds. And in terms of meter, so this will be 5 meter. So can we interpret the graph well? What has happened between 0 to 5 seconds? 0 initially is at origin. It has moved to position equal to 5 meters. Sorry, not meter per second, it is 5 meters. So it has moved at t is equal to 5 seconds. At instance of what is instance of time? T is equal to 5 seconds. Its position is 5 meter. So at t is equal to 5, it reaches a position of x is equal to 5 meter. Then what happens at 15 seconds? Again, this back. What is the position of this particle at t is equal to 15 seconds? At t is equal to 15 seconds, y coordinate is 0. It means y coordinate quantity on the y-axis is 0, which is position is at origin. It has come back to origin again. So just look at this. See what is happening here. See, anything above this is x is equal to 0. Anything in direction x is positive, and anything in direction x is negative. So entire motion, it is nowhere it has gone on to the negative side. So it means entire motion is confined to positive side of x-axis. We started from origin, gone up to x is equal to 5 meter, and again come back to origin. This kind of motion this graph represents. And what else? What else we notice? During 5 seconds, slope is constant, and slope will give you delta x by delta t, which is velocity, which means velocity is constant. What is slope equal to delta x by delta t? If I have to calculate slope here, if I take these 2 points here, 1, 2, 3, 4, 5 units along horizontal direction. And this is, so delta t is equal to 5 seconds. And what is delta x here? Delta x is 1, 2, 3, 4, 5. So delta x also is equal to 5. So velocity or ratio is equal to 5 meter per second. Sorry, 1 meter per second. So during 0 to 5 seconds, it is moving with a constant velocity of 1 meter per second. What happens from 5 to 15 seconds? Again, this is a straight line. Again, this is a uniform velocity. Slope indicates velocity. What is the slope here? Can we calculate the slope here between time to 15 seconds for a time interval of 10 seconds? Slope is constant. So again, you have to calculate the slope also. One way of calculating, let me take this as the first point and this is the second point. And here we know, if you look at this, what is the change in quantity on the x-axis, which is time. So what is this delta t? Again, I'm making a kind of right angle triangle with those 2 points here. So as we move along x direction, what is happening to quantity on the y-axis? Quantity on the y-axis is decreasing, it's going down. And what is the decrease delta x? Delta x is equal to minus 5 meter. And so this is what this indicates. So what is the slope? Slope is equal to minus 5 by 10, minus 5 meter per second. So 0 to 5 seconds plus 1 meter per second, 5 to 15 seconds minus 0.5 meter per second. And if you have to ask what is the displacement between 0 to 15 seconds, to find displacement, we need to find x coordinate at 15 seconds. So 15 seconds also coordinate is 0. And at 0 second also coordinate is 0. So it means x15 is 0, x0 is 0. Hence displacement between 0 to 15 seconds is 0. No displacement. What is average velocity between 0 to 15 seconds? Since displacement is 0, average velocity also is 0. So how do you calculate average velocity 0 to 15? I'll calculate x15 minus x0 divided by 15 minus 0. So again, can we visualize the motion here? Visualize what kind of motion is taking place. Motion means where is the particle at time t is equal to 0? It is origin. And that's how the motion is. 2 seconds, 3 seconds, 4 seconds, 5 seconds, and they start moving. Now we notice it is moving more slowly. 2 seconds, 6 seconds, 8 seconds, 10 seconds. So thus this graph is represented by this video kind of thing. And this is the kind of visualization of graph here. How do you define the direction of motion here? You notice the velocity here. So this, if this direction is positive, whenever particle is moving in rightwards, velocity is positive. When it is moving leftward, velocity is negative. So what we notice here, 0 to 5 seconds, velocity is positive. It is moving along positive x direction. Here it is moving along negative x direction. That's how it can define that. So this brings us to the end of the topic of slope and graph. Next session would be on differentiation, and differentiation is based on understanding of slope and graph. If we understand slope and graph well, then only we are ready for learning differentiation. So I'll stop here and we continue with differentiation in the next session.